Property 5. Standardization and z-scores. Okay, standardization and z-score. To explain what is standardization, okay, let me use the following example. Suppose I give you a list of numbers, given any list of numbers. Okay? Suppose a given list. Suppose a given list we call X list. And what kind of number in the list? For demonstration purpose, okay? I say the number in the list is 1, 3, 4, 5, and 7. Of course, if you at home, you can try some other list too. For my demonstration purpose, I use this list. This list is easy for me to show you the calculation procedure. That's why I use a list, okay? Now, suppose this is a given list. What is the next? Next, I want to find the average of the X list. And this is 1 plus 3 plus 4 plus 5 plus 7. Then I divide it by 5, okay? So 1 plus 3 is 4. 4 plus 4 is what? 8. 13, 20. 20 divided by 5 is 4. And then also find standard deviation of X. And this is 1 minus 4 squared plus 3 minus 4 squared plus 4 minus 4 squares plus 5 minus 4 squares plus 7 minus 4 squares. Then divided by 5, okay? So what do we find on the list? A quick calculation. This is 3 squared is 9. 1 squared is 1. This is 0 squared is 0. This is 1 squared is 1. 7 minus 4 is 3. 3 squared is 9. And then I divide it by 5. So this one is what? 20 divided by 5, which is 4. And square root of 4 is 2. So standard deviation of X is 2. And what's next? From the given X list, each number in the list, I subtract by its mean divided by standard deviation. We call the procedure standardizing X, okay? Now, X minus average of X, then divided by standard deviation of X, okay? I call the resulting score z-scores, okay? Now, what number in the z list? First one, 1 minus average is 4. Divided by standard deviation is 2. Second number, 3 minus 4. Divided by standard deviation is 2. Next number, well, let me put my index here. This is x1, this is x2, this is x3, this is x4, this is x5. Okay? Now, next number, x3. x3 is 4. So 4 minus average of x is 4 again. Divided by standard deviation is 2. And next number, 5. 5 minus 4 divided by 2. And next one, 7 minus 4 divided by 2. Okay? So the resulting scores are minus 3 over 2, minus 1 over 2, 0, 1 over 2, and 3 over 2. So far so good? Now, what's so special about z-score? Clean. The mean of z-score must be 0. And standard deviation of z-score must be 1. No exception. For our example, let me do a quick check, okay? Look at here. Minus 3 over 2, minus 1 over 2, plus 0, plus 1 over 2, plus 3 over 2, divided by 5. And that is average of z, which is 0. Can you see that? This cancel with this, and this cancel with this, so it's 0. Now next one, what's the standard deviation of the least? Standard deviation of the z-score. Minus 3 over 2, subtract the average of z is 0. And I square the term. Next one, minus 1/2, subtract the 0, and I square the term. 0 minus 0, I square the term. And 1/2 minus 0, I square the term. And then 3 over 2, minus by 0, I square the term. And then I divide it by 5. Okay, divided by 5. So in this case, let's see. This is 9 over 4 plus 1 over 4 plus 0 plus 1 over 4 plus 9 over 4 divided by 5. So what do we get? We get this one is 20 over 20, and we take square root, which is 1. Okay? Actually, you can apply this one to any other list of numbers. They should give you the same conclusion. Okay? They should give you the same conclusion. The reason why I use this list is for demonstration purpose. Is for demonstration purpose, because the calculation procedure is easier. Okay? You can go home and check it yourself. You should get exactly what I get here. Okay? Now, furthermore, I would like to make a comment. Okay? Depends on the book used. Depends on the book used. Okay? Depends on the book used. Z-score. Some book they don't call Z-score. They call what? They call standard units. Okay? Or some book they don't call standard unit. They call what? Standard scores. They all refer to what? The same thing. Okay?